Welcome back to my channel. So today I'm going to discuss some important terms and effects which one must be knowing before start reading organic chemistry. The first important concept is the concept of donor ability. What is donor ability? It is the tendency of an atom to donate electrons to electron deficient atom. In the last lecture, I have discussed this reaction. In this reaction, we read that the lone pair of nitrogen they move from nitrogen to the electron deficient carbon of the alkyl halide. Okay. Now, this tendency of the nitrogen atom to donate its lone pair of electron to the electron deficient carbon is called as the donor ability of nitrogen. Now, how we will see or describe which atom can donate its electrons and which atom cannot donate its electron, it depends upon certain factors. The first and the foremost important factor is the hybridization. As we know that whenever atoms combine to form molecules, the atomic orbitals mix and tend to form a set of new orbitals which are called as the hybridized orbitals. Okay. Now in hybridization, we already know that hybridization is like this. This S represents pure S orbital, P represents pure p orbital, and this sp3 it means if we divide an orbital into 100 portion, one portion is for s orbital and three portion is for sp for p3. That means 75% p character, 25% s character. Similarly, 33% s character and 66% p character, and here 50%. Now, according to the concept of hybridization, whenever a molecule is formed as the S character increases, donor ability decreases. Now, what is the reason? The reason here is that the S character is the closest, or the S orbital is the closest to the nucleus. As we move out, as we move away from the nucleus, p orbital is at a greater distance. As S character is closest to the nucleus, the force of attraction would be maximum and energy lowest. Hence, donor ability will decrease. So, from this assumption or from this explanation, we can easily come at a conclusion. As character increases, donor ability decreases. Okay. Now, let me explain this with certain examples. Now, in the first example, first of all, we will see what is the hybridization of the given molecules. See, here the hybridization, how we calculate hybridization, I hope you already know. sp1, p2, sp3. This carbon is sp3 hybridized. In this case, this carbon is sp2 hybridized, and this carbon is sp hybridized. Now, as the S character increases, the donor ability decreases. So that means this carbon will have the maximum donor ability because the S character is least. So correct order would be like this. Okay. Now next example is, we have this carbon on this unit. Okay, first of all we will be comparing the most common thing. Whenever there is a question arising of comparability, what we will be doing, what will be we doing, we will be comparing. First of all, the most common things will be eliminated, and the different things which are different in both the molecules will decide, or will be the deciding factor to see which will have a better donation. See, here also methyl methyl, these are common, will this lone pair, this lone pair is common. Now the question arises, this carbon and this nitrogen, both are sp3 hybridized. Now how we will be deciding that which will be have a better donation or donor ability? So in this case, the concept of electronegativity will be the deciding factor. As we know, electronegativity of nitrogen is greater than electronegativity of carbon. So in this case, the correct order would be like this, because the greater the electronegativity, lesser will be the donor ability. Okay. Now let us consider our third example. Here in this case, see, this nitrogen is sp1 p2 sp3 hybridized, and this nitrogen is sp hybridized. So the S character is greater in this case, so the donor ability will be higher of this nitrogen. Okay, now you have already come across this question in various previous year exams. Here the concept is, as S character increases, bond angle increases. That is, S is directly proportional to the theta. This concept one must be known. Now how will we deciding which nitrogen will have a greater donor ability in this case? Let us first of all consider this example. To understand the correct S and P character in these bonds. Okay, here we will be discussing C. In this case, the bond angle is 60 degree. In this case, the bond angle is 90 degree, and it is greater than 90 degree in this case. Now when bond angle increases, S character, it tends to increase. In this example, as the bond angle is decreasing, the S character in these internal bonds is decreasing, whereas the S character in these external bonds of carbon and hydrogen is increasing, because the bond angle here is greater. So that means the internal bonds will have lower S character, whereas external bonds will have more S character. Okay, now this same concept we are going to apply here, because here a lone pair is present. Now as the bond angle here is also 60 degree, that means the s character in these internal bonds will be more, whereas the s character between this nitrogen hydrogen and nitrogen lone pair bond will be lesser, because the will be more because the bond angle is higher. So the donor ability of this nitrogen to donate lone pair will be lesser. So correct order will be this. I hope this is easily understood to you now. Now the next factor which contributes to the donor ability is the nature of electrons. In nature of electrons, we have to study either our electrons are localized or delocalized. Let us consider an example of amide. Now suppose we have to protonate uh, this compound. Now the question arises, which lone pair will be protonated, either this oxygen lone pair or this nitrogen lone pair. Now if we apply the concept of hybridization, we will see that sp3 hybridized and this is sp2 hybridized. So as per hybridization concept, we will say that this nitrogen should be protonated, that is. However, this is wrong. Why? We need to consider that whether these electrons are localized or delocalized. See, when we draw this compound, we know that the electrons are not localized on nitrogen. They are like this and leads to the formation of. So this oxygen will be protonated and form this compound. Okay, this is the next another factor which decides which will be donated or which atom will not be donated. So now question arises that how we will see that. I have discussed mainly three factors. First is hybridization, then next I discussed electronegativity, then the next I discussed the nature of electrons. Now how we will be seeing the how we will be concluding which will be atom will act as a donor atom or which will be protonated. So for that, one must keep in mind the this sequence, that whenever we have to see which atom will donate, first of all check the hybridization. If by hybridization we can conclude, then we can easily consider this factor. Now if after hybridization we have to conclude the nature of electrons, the electrons should be localized, that will be donated. And then the last factor is electronegativity. Okay, this is the correct order in which sequence which we should follow, so as to come at the final conclusion that which atom will donate its electrons. Now let us consider some examples. See this question. Here we have 1 2 3 4 5 6 sites marked, and we need to decide which site will be protonated first. Here I am using word protonated, that is which will donate its electron to hydrogen or H positive. Okay. So now let us first of all consider this position A. It has a lone pair of electrons. The hybridization of this nitrogen will be sp3. Now first of all we are going to mark the hybridization of all the atoms. Here the hybridization also will be sp3, here the hybridization will be sp2, here the hybridization will be sp3, here also sp2, and here sp3. Okay, now as per the hybridization concept, we must have concluded that the sp3 hybridized atom should be protonated first, that is either this or this. But before coming at a conclusion, we will consider that the lone pair of electrons which are present, either these are localized or not. First of all, let us consider this example, this F point. Here the lone pairs are not localized, but these are delocalized with this carbonyl carbon. Here in this sulfur, also the lone pairs are not localized, and these are in conjugation with this double bond. Now these nitrogen lone pairs, two are not localized, these are delocalized with this carbonyl carbon. So as per this concept of nature of electrons, which atom will be protonated, that is the A position will be protonated. I hope this concept you have clearly understood. This concept is very useful while we have to decide that where our reactions are going to occur, that is the which will be the reaction center where our reagent needs to attack or will attack. Okay, now this is the homework for all of you. I will be discussing the answer in the next video, but before that you need to understand that which site in this compound will be protonated first of all. Okay, I hope you like the video and this video would be helpful for you. Thank you. Bye.